Good morning, students. Hello. Can you hear me? Can you see the screen?
Morning, sir. Yes, sir.
Yes, sir. Morning, sir.
All right, beautiful. Beautiful. All right, so let's have another revision day. So today we are looking at this January 2017. I know we would have done some questions from this paper already, but I think that was much earlier in the program, and so there were a number of questions that we would have skipped. So no problem if we redo the questions. More maths equals better maths every time. So it's not a problem if we do a question that we have done already. It is revision, and sometimes revision includes actually reworking a question that you have done before, because we want to master these things. We want to reach a level of perfection in terms of our approach to these things. So sometimes we need to see the working done multiple times so it can stick. And when we get a question similar in the exam, then we know exactly how to approach it, and we don't have to spend time thinking. The less thinking you have to do in the exam room is the better, and you think less when you know. All right, so we go through the phase of learning, understanding, and then we reach a level of knowing. When we know, then it's much easier. So the more things we know, the better, the easier the exam questions will be for us. And that is what we want to get. To get to that level, we have to practice a lot and redo questions and do them multiple times and master what we're doing. All right, and that's what we're preparing for. So we're gonna run through this paper, guys. We're gonna do the questions from the topics that we have covered. I sent it in the group, the questions that we are doing today. And you see that based on the questions that I sent, you see that we would have gone through a good bit of the syllabus already. We're at a good place, and we're just at the end of January. So, remember, we want to finish everything in March. We want to be ready for the exam at the end of March. At the end of March, we should be able to take the exam and be able to do all the questions. And then between March and May, we are mastering, or we're perfecting, and we're eliminating mistakes. That is the aim. But we should be able to do our exam paper in March, at the end of March, right at the beginning of April. All right, that's our aim, that's our objective, that's what we work towards, and that is what we will achieve. All right, so let's go. All right, so this is the January 2017 exam paper, same syllabus. There's some minor adjustments to the number of questions, but that you do, because this paper has 11 questions. Your syllabus, there are 10 questions. We have to do all the questions. All right, so let's go. First question here is our calculator question. Using a calculator, otherwise they want us to work this out. So again, it's a matter of plugging this in the calculator exactly as it is. And I'm emphasizing, guys, that you need to get that calculator. I'm still seeing too many persons with not the best calculator in the class. We want to have the best calculator to give us our best chance of getting every answer correct. So we want the calculator that can type this and see it as it appears there. We call it the textbook display calculator. I'm going to send it in the group another time, the one that I wanted to get. I don't want it to get one like it. I want it to get the one that I tell you. All right? Because if you get one like it, it might not be the one that I'm telling you to get. Pay attention to the details. All right, so I want to type this fraction exactly as it appears. So it's a fraction, and we're starting with a mixed number there of 3.5. Look at this calculator over here, you'll see me typing exactly as it appears. And then we're doing a multiply, and that's another mixed number, or mixed fraction, 1 2/3. And then we're dividing all of that by another mixed number, which is 4 1/5. And the question say you could use a calculator. And the calculator you will give you as a fraction. If you use a fraction, if you use a fraction function to do the calculation, but if it gives it as a decimal, there's a way to show it as a fraction. Right? There's a little button that says S to D, something like this, that will convert it back to a fraction. Right? I think that's what the button is. But I'm going to get it on my calculator here as a fraction because I wanted the exact value. And the exact value is this. So you don't want R or this one. You don't want to put this one because that is not exact. Even though the line on top means you're repeating the 8, you know, it really means 1.3888. So really and truly, if you put it like this and put the line on top that the 8 is repeated, yeah, but I don't think that's what they want. So let's not get into say we're gonna give them that. Just give them back a fraction, which is in an exact form. This one up here or this one down here. All right, and because they gave me mixed numbers in the question, I can give them back this mixed number as an answer. It will be exact. So I'm just going to write that this is equal to 1 and 7 over 18. If you write this one, 25 over 18, that's okay as well. All right, let's continue. They want us to work this out again with the calculator. So we're going to do it. Use the calculator and do it. So you're seeing now that, as I always tell people, when you get to question 10 and 9 and 8, you don't have to, for example, doing a question and working out this part of it. Right? You get everything, you get an expression similar to this, you work it out and put the answer. Don't waste time working out the individual parts. There's no time for that, and a lot of the time there's no space for that on the paper. So let's do this one now. I'm going to type this one in the calculator up here. So it's 5.47 All right, students, we dropped off. Just give me a second. Let me log back in with this device. You know, the internet can be unstable sometimes. Just give me a moment. Let me get this back up and running. Let's get this back up. Hope it is still recording. Let's see. All right, can you see the screen now again?
Yes, sir.
All right, let me just check if it's. Let me just check if it is still recording. Let me just go a quick check. Hold on a second. Let me just check quickly. This is recording. All right. So apparently we are still recording. All right. Good. Let me see. I'm just checking if this is still recording, guys. I don't want it. All right. Yeah, we're good to go. All right. So we're still recording. All right. So I'm saying we're gonna type this in the calculator. I don't know where I lost you, but we're gonna type this in the calculator exactly as it appears there. So it is 5.47 minus the square root of a fraction on the numerator is 0.1014. On the denominator, it's 1.5. And then all you need to do is check to make sure that what you have here is the exact same thing that we have typed in the calculator. Just check every digit, everything. Make sure it's perfect. And I'm getting an exact answer, 5.21. So I'm going to write the 5.21. This is equal to 5.21. And I'm going to trust that answer is correct. 2 marks, 2 marks. We want those marks. All right. Let's continue down here. All right. Let me make the calculator look smaller. All right. So here now, it says the table below shows the number of tickets sold for a bus tour. It says some items in the table are missing. All right. So this column is the number of tickets sold. This is the cost per ticket, cost for one ticket. This is the total. So this is the line for juvenile. This is the line for youth. This is the line for adults. And what it is that we are multiplying this number of tickets by the cost of the ticket here, this column, to be equal to the total over here. So we can set it up like a formula here. So this is like the number of tickets column multiplied by the cost equals the total. That's what's gonna happen. That's what's gonna be happening. N times C, number of tickets times the cost equals the total. And so we can transpose this formula to do our calculations down here. All right, so here now, the question is to find the value of P first. So it means that 5 times P is equal to this. You put a little multiply here to show it, and equal there. Just to show what we're doing. All right, so we know to calculate P, 5P, 5 times C is 5P is equal to 130.50. And then to find the P, we're going to divide by the 5. So the P then is going to be 130.50 divided by 5. Now remember, P is a dollar, is a money, you know. P is the cost of one ticket. So you have to express it back as money. Right? Well, 2 decimal places, whatever we get. Let's put it over here. So it is 130.5, same as 0.50 divided by 5. And I'm getting 26.1. 26.1. But because it's money, you have to put 26.10. And I don't have to put a dollar sign on it because if you notice the numbers don't have the dollar sign on them here because the dollar sign is in the table there. So it means that the P value right here would just be 26.10. I have to put the 0 because it's a money figure, it's a cost. All right, that's the first part. The next part wants us to calculate the value of Q. So this is where Q is, and again, it is these two you multiply. So it's this times this, that will be equal to the Q. So we can say the Q is equal to the product of these two. We can set it up that way, down here. So the Q is simply going to be equal to 14 times 44.35. And again, the Q is money. Even though we don't have to put a dollar sign because it is here, we have to put it to 2 decimal places because it's money. Money is always expressed 2 decimal places. So we're just going to multiply the 14 times the 44.35. That's 620.9. We have to put the 0 on it. So Q is 620.9 0.9, we have to put the 0 because it is money. All right, that is that. All right, come on, give thanks. Oh, you did some more. All right. Okay, all right. Thanks much. Yeah, cool. All right, guys. Sorry about that. Then now we come to over here. It says an adult ticket costs twice a youth ticket. So the adult ticket is twice the cost of a youth ticket. So let's look back at it now. So what they're saying is that the cost of an adult ticket, remember this is where we put the cost in now. Let's do this part in red. And the cost of a youth ticket is this. So it means that the adult ticket is 2 times, let's put it there. The adult ticket is 2 times 44.35, which becomes, if you double this, you're gonna get 70. If you double this, you're gonna get 88. So this is 88.70. That's the cost of the adult ticket, and it's okay to do your working on the paper like that, because this is going in as a part of your answer. So it's okay to write on it like that, let the examiner see. All right? So down here now, we know that the cost of the adult ticket, therefore, is $88.70. So I'm going to write it here. This works out to be equal to $88.70. That's the cost for the adult tickets. All right? I'm going to put that there. It says calculate the value of R. So let's look back at the table now. They want us to calculate this R. And so it is this times this that is equal to this figure right here. That's what is happening. All right? That is what is happening. So we're going to write, let me just put it right here. So it's the 88.7 times R that is equal to this. Let me just write it here and then copy it down. 88.7 times the R, or the R times the 88.7 is equal to 2483.60. And to get the R now, we just need to divide by the 88.70. Let me copy this down and move it down. All right, and put it where it should go. Right in this section here. All right, that is that. And so to get the R, as I said, we have to now divide this figure. Take this figure and divide it. All right, so the R becomes 2483.60 divided by 88.70, which is same as 88.7. 88.70. I remember R now is a number of tickets, you know, so you're not going to put any unit, any decimal on it. If you notice, all these numbers are just whole numbers, right? So we don't have to put any decimal on that one. So we're supposed to get a whole number of tickets. So let's work this one out. So it's going to be 2483.6, same as 0.60, divided by 88.7. And so we get 28. So R is 28. That's the first part. Everybody good so far? Everybody okay with that?
Yes, sir.
All right. Next part now. Let's go back for the blue. Next part now says here now. It says the bus company pays 15% tax on each ticket sold. Calculate the tax paid by the bus company. So what it means, we're gonna have to add up all the money that they collected and calculate the tax on it, which is 15%. Right? 15%. Right? Because it's for each ticket sold. Right? So we're gonna calculate the total that was sold and do the tax on it. So remember, the only figure missing right here is a Q, and the Q was the 620.9. So let's put it there. 620.9. Let's put it there. 620.90. Then I'm gonna do the total right here. So let me move this, and I'm gonna say total. Put the arrow point in there. I'm gonna add up these for the total. All right, so it is 130.50 plus 620.90. I don't have to put a 0 plus 2483.60, and that is a flat a flat 3235. So calculate the tax on that 3235. And leave it in the table. Leave it in the table. Let the examiner see how you got the figure. So I want to say the tax, therefore, is 15% of, what is the figure again? 32, put the dollar sign, because this time you're actually calculating money, right? I'm going to put the dollar sign 3235 and work it out. So we're going to do 15%, which is same as 0.15. 15% is 0.15. I divide the 15 by 100. And then multiply this now by the 3235. And we get dollar sign 485.225. 25 cents. And that's the answer right there. But good at that? But okay? Any questions there? All right. But it's okay. So let's continue. Let's continue. Number 2. All right, then number 2. I don't think I need a fraction, the calculator now. So number 2 wants us to write this as a single fraction. When we are doing fractions, guys, whether it's algebraic or numeric, this one is algebraic because it has the letters in it, the x, right? Those unknown variables are unknown quantities. We want to make the two fractions related. Fractions are related when they have the same denominator. When they have the same denominator, you can just add a numerator and put back that common denominator. So I want to make these two fractions related. I don't want to use the rote method that they teach in prep and primary school. We do LCM, and you do the 3 times 4 is 12, and then you do the 12 divided by 3 is 4, and then 4 times that. That is rote learning. That a person don't understand what they're doing. They do it that way. I want the two fractions to be related. So to make the two fractions have the same denominator, I'm looking for the lowest common multiple of the 3 and the 4. That lowest common multiple is 12. For this denominator to become 12, I need to multiply it by a 4. Because I multiply the denominator by 4, I have to multiply the numerator as well by 4. Now do a similar thing to this fraction. I want this denominator to become 12. So I have to multiply this denominator by 3 for it to become 12. Because I multiply this denominator by 3, I have to now multiply this numerator by the same 3. So like I multiply by a 1 and multiply by a 1. So the value of the fraction is not changing. And if I didn't have these, a way I could do it, I'll show you quickly. Delete. I could multiply this denominator up here and down here, which is essentially what I did, and multiply this denominator up here and down here. And the two denominators will become the same. All right, but that's what we have. So let's continue now. So this fraction becomes 4 times this numerator is 8x plus 12. 4 times this denominator becomes 12. Plus, that's this plus. I'm doing 3 times this numerator now. I get 3x minus 12 over this 3 times 4 under here is also 12. Know that the two fractions have the same denominator. They are related. And so to solve this, or to simplify this, we can put back that common denominator and just add up the numerator values. So the like terms, 8x and 3x is 11x. 8 plus 3 is 11, 11x. And then 12 and a negative 12 becomes 0. 12 and a negative 12 added together are going to give us 0. Like 12 minus 12 is 0. So basically, this is the answer, 11x over 12. That is it. Any questions there?
No, sir.
All right, good. This next one says, write the following statement as an algebraic expression. The sum means plus the adding of a number. They don't give us anything for the number, so we're going to call it n or x if you want it. And its multiplicative inverse. The multiplicative inverse is 1 over n. The multiplicative inverse of n is 1 over n. And they said the sum, so I'm going to put the plus in between them here because we want the sum, so put the plus right here. That's the sum of a number and its multiplicative inverse. Is means equal. 5 times the number. This number we call it n. So that is 5n. That's what that statement just said. The sum means n plus the multiplicative inverse of n is 1 over n. Is means equal 5 times the same number. If you use x, you could write x plus 1 over x equals 5x if you wanted to use x as your number. Don't matter whether you give them this or this, still correct. All right, so we could say that or this, whichever one, it don't matter. All right, so maybe I would just give them that one and just use n for the number. That's it. Give them that in the exam, you're good to go, get your marks, move right along. They didn't want you to solve it, they just wanted to write the statement, the expression. All right, let's continue. Down here, they want us now to factorize. You must recognize this as the difference of two squares. This is a square minus another square number. What it is that we're going to write this as a perfect square of 6. That's what it is. So this actually first becomes x squared minus 6 squared. Let's remind ourselves of the rule for the difference of two squares. A squared minus b squared. Difference of two squared become the difference of the numbers a minus b times the sum of the numbers a plus b. This is another must-know thing. So this therefore is just going to become x minus 6 times x plus 6. That is your answer right there. When you factorize this completely, that's what we get. Difference of two squared. But good at that?
Yes, sir.
But okay? All right, good. Then we come to this one, which is to factorize as a quadratic with 3 terms. And we're going to use the method where we split the middle term. All right? So we want to split the middle term. How do we split that middle term into 2 terms? First, we're going to multiply the 2n coefficient. Let's do it over here. Searching for factors of that will give us the middle term. So it's 2 times the negative 12 is negative 24. They were searching for factors of this negative 24 that add to a positive 5. Now I can already see that it's 8 and 3 now. 8 and 3. Right? Because the difference, the factors of 8 and 3 is 24 and the difference is 5. But let's say I don't see that it's 8 and 3. What would be your process to finding it? Let's look at the process. One, factors of the negative 24 that add to the middle coefficient of this positive 5. All right? I normally do it like this. I'm searching for factors of the negative 24. Since you want factors of a negative number, one factor will be positive and the other one will be negative. All right? One factor will be positive and the other one will be negative. Hold on a second. Right. So the first 2 factors, you're going to give the larger one the same sign as this. Let me say it again. Since you want factors of this negative 24, one factor will be positive and one factor will be negative. Since you want the sum of those 2 factors to be positive like this, you're going to give the larger of those 2 factors the same sign as this, which is a plus. So let's write down the first 2 factors of 24. 1 and 24. Remember, I know it's 3 and 18, but I'm just showing you the process. I'm going to make the larger one positive like this. Positive. And the smaller one negative. So those are my 2 factors. And then I add them. What do they add to? 24 and negative 1, they add to 23. I'm going to put an X on this because I'm really searching for 5. So I'm not going to be using these 2 factors of 24. So the next 2 factors of 24 will be 2 and 12. Again, I have to give the larger one the same sign as that. So I'm going to make the larger one positive, smaller one negative. But then 12 and minus 2 is 10. I don't want 10, I want 5. So I'm going to cross this out again, put an X on it. The next 2 factors of 24, 3 and 8. Make the larger one the same sign as this, which is positive, and the smaller one negative. But then 8 minus 3 is 5. Same 5 that we want up is a positive 5. So good. So what it means is that this 5x, I'm going to split it into negative 3x plus 8x. That's how it works. I'm going to split that 5x into negative 3x plus 8x. Or you can put the 8x in front and say 8x minus 3x, because 8x minus 3x is 5x. So we have found the values that we're going to split the middle term into. All right, we're going to use to split the middle term. All right, so let's do it now. So remember now we're splitting this middle term. So this whole expression is going to become, this remains unchanged, which is 2x squared. Then this 5x, I'm going to write it as 8x minus 3x. I always do a little checkpoint right here so that what we split this into will give us back that middle term. That's a checkpoint in this factorization. And then this negative 12 is going to come back over here. That did not change. And so we now have 4 terms that we can factorize by parts. Right? So one of the highest common factor in these 2 terms to begin with. The highest common factor is 2x. Highest common factor there is 2x. I'm going to factorize the 2x out of these 2 terms. 2x out of this leaves me with an x in here. 2x out of x, not 3, leaves me with an x. 2x out of this leaves me with a positive 4. What I always say to the students is that this positive x plus 4 must be a factor from these 2. And to ensure that I get it as a factor, I normally just write it back first. I'm going to write by the x plus 4 first. And then in between here, I must have plus a value or minus a value in between there, not just a value. And it is a factor from these 2 expressions that gives me the x plus 4. That factor is coming out inside here. To find that factor, what you can do is, for example, divide this negative 12 by this positive 4. Just divide it. Negative 12 divided by a positive 4 is negative 3. Or you can divide this negative 3x by the x. You're still going to get negative 3. So the factor coming inside here is negative 3. I need it to be plus or minus a value because it is these 2 that is going to form a factor in the next line, because the x plus 4 is now a common factor on the expression. So the next line, you're going to put these 2 together as a factor, which is a 2x and a minus 3. Those come together as the factor with the x plus 4. And that's your factorization. Now, if you do it another way, well, if you do it and you write it this way, with the x plus 4 in front, and then 2x minus 3 second, this is still correct. All right? So whether you do it like this or like this, it don't matter. All right? Same result. And we could have done it here by putting, instead of 8x minus 3x, we could have put minus 3x plus 8x, and the result will be the same. All right? So let's continue to the next part. Everybody go with this?
Yes, sir.
Okay? All right, beautiful, beautiful. Let's continue. Down here now gives us this formula right here. That's a formula for volume of a cylinder, pi r squared h. They want us to make R the subject. So I want this R to be the subject. And I always say to students, let me write it out. If I have V equals pi r squared h, I simply want to move everything away from the r. I want to get rid of this pi, I want to get rid of this h, I want to get rid of this square. But when you practice, you know the proper sequence to do it in. All right? So we're going to get rid of the pi and the h first. So like you divide the pi under here and you divide the h under here as well. Or what we say theoretically is that you divide both sides by the pi times h. So you divide this side by the pi times h as well. But the shortcut is to say we take the pi and divide it under here and take the h and divide it under here. Why? Why would we divide? Because over on this side they are multiplying. The pi is multiplying and the h is multiplying. All right? And the inverse of multiply is the divide. So if we put on the next side, it's going to be divided. So the first step, as I said, is to divide by the pi and the h. So that's going to be my first step. So I'm going to get V divided by pi h equals r squared. R squared is left. Then I need to get rid of the square. But the inverse of square is square root. So basically, to eliminate this square, I need to square root this side. But if I square root the right side, I have to also square root the left side. And the square root of the square will eliminate the square. The square will eliminate the square. And so the right side is just becoming r. All right, so I'm going to get that the r now is equal to, and this remains as is, the square root of v over pi h. And see r is my subject, but because I said subject, normally subject goes on the left side. So I'm just going to rewrite this. I'm going to shift this over. I'm just going to rewrite that. I'm spin it around and put the r on the left side, just to make sure that since I said subject, I'm going to express it that way and say r then is the square root of v over pi h. So oftentimes, the way to make something the subject is to just transpose everything away from it. All right, and do it sequentially in the correct sequence. All right, better go to that. Right, okay?
Yes, sir.
All right, let's go to the next part. The next part says we are given that this thing is equal to that. So you can see that that's a standard quadratic, and this is after you complete the square. All right, but the thing is, in the standard, we don't know A and we don't know B. And inside here, we know all the values. They want us to work out the value of A and B. Now, to me, we're going to do it the easy way. To me, the easy way to do this is to expand out this, put it in this form, and then you will see what the A is and what the B is. To me, that's the best way to do it. Right? Expand out the right side. So I'm going to say, this will be the left, this will be the right side. I will say the right-hand side. If I expand it out, now first I have to expand this perfect square. And we expand a perfect square, remember you get 3 terms. Let me write it over here in red for you. If, for example, I expand x plus y squared, it becomes the first term squared, which is x squared. Then I get twice the product of a 2. I will get twice the product of 2. Multiply the x and the y and double it. So the middle term is 2xy. And then I get the second term squared, which is y squared. I'm going to apply that same concept or that same principle in expanding that. So let me move this a little bit low. All right, so the right side, I'm going to call this the right side, the right-hand side, just for reference. And this is the left-hand side. I'm going to expand the right-hand side since I know the values on it and try to write it in a form looking like the left-hand side. All right, so write this better. Left-hand side, left-hand side. All right, so the right-hand side. Firstly, I'm going to expand the squared term in the bracket. So I'm going to the first term squared is x squared. Then I'm going to get twice the product of these two things. How you do that? You multiply them first. The x and the 2 is 2x. And you double that to 4x. Plus 4x is the middle term. And then the second term is 2. 2 squared. You're going to square that, you're going to get 4. So this is what I get from the bracketed term. I can put the bracket around it, or I don't need to put the bracket around it. Then now this negative 3 comes back unchanged. I've not done anything with it. Then these are the only like terms that I can simplify. So this then becomes x squared plus 4x plus 1. So if I compare this now with the left side, so let me write it down, compare. Let's write it, compare with x squared plus ax, x squared plus ax, x squared plus ax plus b. Then you will see that the a is equal to 4 and the b is equal to 1, because the sign is the same, you know, plus, 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 plus. So we're just looking at the numbers because the signs are the same. There's no contention with the signs. So the b is equal to 1. And that is it. As easy as that. I'm just trying to explain it, guys. I mean, This could be done like in a jiffy, but I'm just trying to ensure that you understand it. But okay with that?
Yes, sir.
Sure.
All right, good. Next part. That finishes that question. So skipping over number 3, right? Sets like this question not on your paper 2 anymore, but you will get sets on a multiple choice. So sets is something that we're still gonna have to do. I think the set between 3 and 5 sets questions on your multiple choice exam. So we're gonna have to do sets, but we're not doing it yet. All right. And I'm skipping over this as well. This is geometry construction. One of this closer to the exam as well. As a topic you have not yet done. So I'm skipping over number 3 for that reason. Then we'll come to number 4. Number 4 is a functions question. We have done function before. This first part, well, it gives us these two functions, f of x and g of x, like those. And the first part wants us to calculate g of 0 plus g of 5. So the g of 0 means we're going to plus 0 in the g function. And the g of 5, we're going to plug 5 in the same g function. So this is going to become equal to the g of 0 first, means 0 is coming in here. 3 times 0 plus 1 divided by 2 plus, that's this plus, g of 5 now, 5 is going there where x is. 3 times 5 plus 1 over 2. So we end up with 2 fractions to add, but the fractions are related. Now we can just look at it now. This numerator becomes a 1. So we get 1 over 2 plus this numerator becomes a 16 because 3 5s, 15 plus 1 is 16. Now you might be tempted to write it as 16 divided by 2 is 8, but I'm going to leave it with the fraction for now and put 16 over 2. And because they are now related, I can just add the numerator and put 17 over 2 as my answer. How are we with that? Everybody good? Everybody good with that? All right, beautiful. Now this part now wants g of f of 5. Now, all right, so something interesting is happening here. So remember that g of f of 5 really means, no, not g of f of 5, f of g of 5. It really means f of g of 5. We have to work out the g of 5 here first. But we technically have the g of 5 already, you know, because it is what we had here, which gave us this calculation, and that is an 8. So we can extract from this that the g of 5 is actually equal to 8. So we don't have to recalculate it. You don't need to recalculate something that you already have. Because the 16 over 2 was a g of 5, which is 8. I'm going to extract that. And I'm going to use that g of 5, which is 8, as my figure here. So then I'm therefore calculating f of 8, because I've used the fact that my g of 5 is 8. So that is 8. And then now f of 8 now means I want to put 8 in the f function right here. 8 is going in the f function. All right? So therefore, this becomes, go back for the blue. This becomes 4 times 8 minus 7. Remember now that the f of x is 4x minus 7. So it's 4 times the 8, but the x is 8 if it's f of 8, minus the 7. That's what we have. Now 4 times 8 is 32. 32 minus 7 is how much? What is this? 25? What's your quote? 25? 4 times 8 is 32. So we have 32 minus 7. That is 25. I'm saying it's 25. My mind is telling me it's 25. Am I correct?
Yes, sir.
Yes, sir, it is 25.
All right, thank you very much. All right, so that finishes that one. Everybody good with that? Everybody understand that we had to work out the G of 5 first? But we had it already, so we didn't have to do it again because we use it up here. So it's in this expression, which is 8, right? I don't want to calculate the same thing twice. Right? We have to be smart about it. So I would actually leave these lines on my exam paper, you know, as I have it here. Everything I see, I'll put on the exam paper and this arrow. I'm leaving everything there on my exam paper. What I do on these papers normally is the same way I would do it in an exam. And I know I will get a grade 1 with an A profile. So if you do it like I do it, then you're good to go. All right, let's continue. This now wants f to the minus 1 of 1. So we're going to do f to the minus 1 of 1. Let's see. We're going to use a method where we calculate f minus 1 of x first. So let's write it. We're going to do f to the minus 1 of x first. We'll basically say what we're going to do. And then we will calculate f to the minus 1 of the 1. All right, so we need the inverse of f first. Inverse of f of the f function. Let's remind ourselves of what the f is. So the f, remember, is 4x minus 7. I was leaving off the x that is there, not necessary. Some teacher will just call it y, but no problem. I'm leaving off the x. That's my function. I'm going to inverse it to find the f to the minus 1. So the f, which is range, becomes domain in the inverse function. And this x, which is domain on the function, becomes range in inverse function. Range is really f to the minus 1. As I said, some teacher will just call it x and y and put a y right here. Can interchange x and the y. But no problem doing it this way. Don't put by the minus 7. Then it's no matter of making this a subject. Because that's what we're trying to find first. You know. I'm going to transpose the 7, add it, and then divide by the 4. So let's see if we can see this step now. It becomes x plus 7 over 4. That leaves that f to the minus 1. So this is f to the minus 1 of x really now. So if I want f to the minus 1 of 1 now, oh, not x, I want f to the minus 1 of 1 right here, 1. F to the minus 1 of 1 is what I want. So then f to the minus 1 of x first, then we can do the f to the minus 1 of 1. What you have here really is f to the minus 1 of x. That's what we have found. So I can put in by the x right here. That's f to the minus 1 of x. And now we can do f to the minus 1 of 1. So we can say, therefore, that f to the minus 1 of the 1 means that the 1 is now coming here for the x. It becomes 1 plus 7 over 4. And 1 plus 7 is 8. 8 over 4 is 2. So the answer here is a 2. Any questions there?
No, sir.
All right. Good, good, good. Let's continue. This now is a coordinate geometry. Straight formula. They give us these 2 points. And they are endpoints of a line segment PQ. And I want us to determine first the gradient of PQ. Remember, gradient is difference in y over difference in x. Let's call it small m PQ for gradient of PQ. Difference in y over difference in x. So we're going to do the difference in the 2y. But let's say I'm using this point minus this point. Remember, you subtract a point, 1 point minus another point. We're doing the rise over the run. And the rise is the difference in the y value. So this y value minus this y value. This one. That's the difference in the y values first. So it's 7 minus this y value is a negative 1. Divided by this x value minus this x value. So on the denominator, the difference in the x value, which is a run, difference in x value, so it's 2 minus 6. So because I start with this y value minus this y value, when I'm doing the difference in the x, I have to use this x value now minus this x value. I have to subtract the points in the same way, the coordinates of the points. I have to subtract them in the same way, same direction. Very important for us to remember that. This now becomes an 8. Okay, all right, and there we have enough space. This is an 8. Because this minus is a plus, so that's an 8. And that's a negative 4. 2 minus 6 is negative 4. 8 over negative 4 is a negative 2. So my gradient of PQ is negative 2 right there. Done. That's gradient of that line. Gradient of PQ. Next thing I want is the coordinates of the midpoint of PQ. Remember, midpoint is like an average point. It's like an average point. So the midpoint, we're going to give it capital M. So the common M is for gradient, capital M. It's the average of the values. Let's write down the points again. So P is 6, -1. P is 6, -1. And Q is 2, 7, right? 2, 7. 2, 7. So the midpoint is just first the average of the X values. Midpoint is like an average point. So it's the average of those two values. So it's 6 plus 2 over 2. And the average of the two Y values, that's this and this. -1 and 7. -1 and 7, average them. And so this works out to be, this is 8. 8 over 2 is 4. This is 6 because it's -1 plus 7. Same as 7 minus 1 is 6. 6 over 2 is 3. And so that's the midpoint. The next part now wants equation of the perpendicular bisector of PQ. The perpendicular bisector of PQ. We need to know what this means. Let me just give you like a schematic of it so we can see what they're talking about. So 6, -1, 2, 7. So it's like you have a line like this. And down here is P. And down here is Q. It's like a schematic of what they have, right? The perpendicular bisector, let me put it out in red for you. Firstly, it's a bisector. Means that it cuts the line PQ in half. If it cuts it in half, it means that it passes through the midpoint. That we just calculated right here. That's the midpoint. It passes through that point, M. That's the first thing. Then it is perpendicular. So it passes through the midpoint and it is also perpendicular. And so it goes like this. It is perpendicular to the PQ. So that is the line that we want to know. Let's just put a 2 on it and call it line 2. The perpendicular bisector, we're calling it line 2 in this question. Remember, this is perpendicular now. So to find the equation of that second line, the perpendicular bisector, we need to know two things about it. To find the equation of any line, we need to know two things about it. We need a point that it passes through, and we also need the gradient. We have the point that it passes through already because it passed through the midpoint. So we know that it passes through the midpoint. So the point we're using is the point M, midpoint. So it passes through the point M. The red line passes through the point M, which is 4, 3. The next thing we need is a gradient of line 2. But it is perpendicular to PQ. Perpendicular lines have what we call a negative reciprocal gradient. So the gradient that we want, which is the gradient of line 2, let's call it M2, is going to be equal to -1 over the gradient of PQ because they are perpendicular. This calculation can be done easily by flipping the gradient of PQ and changing the sign. What is the gradient of PQ again? It is -2. Or we can just take the -2 and put it under here. And so we will see that this is -1 over -2 becomes a half. So this time we can just do it like that. Right? So that's the gradient of the line that we want is a half. So we're using this point and this gradient to find the equation of this perpendicular bisector, that red line. So the equation becomes, we're using the BFF formula for the equation of a line. Y minus ym, some teachers say y minus y1, equals the gradient of the line, is gradient of the red line we want to know. So we have to use the gradient of that line, the red line, the perpendicular bisector, M2, into x minus xm. M is referring to this point right here that the pass through, or this point right here. That's a capital M. So that's a capital M right here. And this also is a capital M. That's the pen not giving me as a capital. So basically substituting the values. So this is y3 now. Let's write it out. Let's write it out. So it becomes y minus ym is the y value at the point right here, this 3. Equals the gradient of the line is a half into x minus xm is the x value right here. X value at the point, which is 4. Putting a 4 there. Then because this half times this 4 going to give me a whole number, I'm going to multiply this half right through here. And I'm going to get y minus 3 equals half x, and then half of that -4 is -2. And then this -3 comes over here and becomes a +3, and the +3 and the -2 give me a +1. Let's write it now. So when I take this over here, we're going to become a +3. 3 minus 2 is 1. So I'm going to get y equals half x plus 1. And this is my answer. This is the perpendicular bisector, equation of the perpendicular bisector. Everybody okay with that? Everybody okay with that? All right. The red line is the perpendicular bisector. All right, that finishes that one as well. Let's move on to the next one. So we're not doing this question because we're going to do this topic after we finish with circular measures this week. So this is like our next week topic, right? It will come under plane and solid geometry, talking about similar shapes and so on, right? Congruent shapes and all these things. All right, so we're going on to this topic next. So we're skipping over this one today. All right, so by next week we might be doing questions on this. But we did do this topic, which is transformation. As soon as I see these triangles, I know it's transformation. It says the graph below shows triangle DEF, that's this one, and its image D prime, E prime, F prime after a transformation, and they're not telling us what it is. But I can look at this and start to determine what kind of transformation it is, or we can know. Take, for example, DE going this way on the object, but DE is going this way on the image. So it means that this was rotated up that way. So I know that anti-clockwise 90-degree rotation. You know. It was rotated. All right? So the anti-clockwise 90-degree rotation, but a rotation must have a center. So usually with these questions, the origin is the center. I'm just going to check if this time the origin is the center. So I'm going to see if the origin is the center. I will double check it. So how can I check it? I can, for example, say, okay, I know it's 90 degrees anti-clockwise, you know, and it must be from the center. It would have to be rotate 90 degrees anti-clockwise. So the coordinates will also have to rotate this way now. How do I find out the coordinates? Am I drawing a line out here to E? I'm testing E. I'm testing the point E to here to see if it works. That will be the X coordinate line, and that will be the Y coordinate line. That's like a L. If I rotate these coordinates 90 degrees this way, then this horizontal piece of the coordinate will become the vertical piece up here, and it is out to 4 now. So it's going to come up here, 4 units long up here. And this piece at the top of it, which is 2 units long, would come across here. That is correct. So I'm seeing that when O is the origin, my coordinates rotate 90 degrees anti-clockwise for E. Let's test if it does it. Let's test if the same thing happens with another point. Let's look at D. Let's test it for D. You only need to test it for 2 points. Work for 2 points and you're good to go. Let's test it for D to here. Let's look at it. So I'm testing if here is my center. The coordinates to D would be 1 across, 2 up. If I rotate this 1 across, 2 up, this way, anti-clockwise 90 degrees, this 1 across will rotate to here and become 1 up instead. And this 2 at the top will go 2 on the head here at the end of it. So that will take me from D to D prime. So because that is happening with the coordinates, if I rotate the coordinates anti-clockwise 90 degrees, it's taking me to the same, or taking me to the image points, then I can confirm that my center of rotation is here. I need you to watch over the video and try what I've said. Do it yourself and get the understanding. Most times the center of rotation is the origin. We will do questions with the center of rotation, but not the origin, and I'll show you the other way to do it. All right, I can remember one question recently where the center was not the origin, and we had to use 2 perpendicular bisectors of lines joining corresponding points. We did that question already, but I'm certain we're going to do it again at some point. All right. So now I know the rotation. It's an anti-clockwise rotation about the origin. So I know it's about the origin. I know about O. This point I call it O. If they ask for the description. But let's answer the question. That was just me working ahead of time. All right. First part wants us to write the coordinates of the point E right here. So it's 4 out this way is the X value, and 2 up is the Y value. So that's 4, 2. So I'm just going to write E is the point 4, 2. It's not complicated. 1 free mark. Want it. Next part says describe fully the transformation that's from DEF onto D prime, E prime, F prime. We worked it out, so we can just write it now. It's an anti-clockwise 90-degree rotation about the origin. Let's write it. And anti-clockwise that's the direction. 90-degree rotation about the origin. This is good enough. If you put this on the exam paper, you will get your marks about the origin. That's it. The description of a rotation must include its name, which is rotation, and the 3 components of rotation. The 3 components of rotation are the angle that we should have here, the direction, which is anti-clockwise, and the center, which is the origin. You must give the name and the 3 components. Remember, anti-clockwise rotation is positive clockwise rotation. So instead of saying anti-clockwise 90 degrees, what we could do is just leave out the word anti-clockwise and put the positive in front of this. Because positive rotation is anti-clockwise. If a rotation is clockwise, then we can put the negative. So for example, if it was clockwise 90 degrees, we could put the negative 90 degrees. Clockwise rotation is negative. It's something that's good for you to know, guys, because they set those in exams. I've seen it, for example, on multiple choice papers before, that the anti-clockwise rotation direction is positive, the clockwise direction rotation is negative. It is a standard for mathematics everywhere. Clockwise rotation is negative. Anti-clockwise rotation is positive. When you do pure maths at a higher level or add maths, you will appreciate that even more. All right? But this is good enough that we have right here. But go to that. But okay?
Yes, sir.
All right. Next question says, on the grid above, draw D prime, E prime, F prime, a reflection of DEF in the x-axis. Now, instead of saying in the x-axis, question could have also said in the line y equals 0. I've seen that. Because you have to know that the x-axis is a line y equals 0. I'm just doing these things for us to remember. So instead of saying in the x-axis, they could have said in the line y equals 0. So I want us to reflect it in the x-axis. I'm reflecting the prime one. All right? So reflecting this one now in the x-axis. Reflecting it in this line. That's x-axis, y equals 0. So you do your reflection 1 point at a time. So let's say we're doing E first, D first, D. D is 1 unit to the mirror line, it's going to go 1 unit on the other side. So your D prime, D double prime is going to be here. D double prime, and label it. Then F, let's say we're doing F, is 1 unit to the mirror line, it's going to go 1 unit on the other side. So it means that it is coming here. So we're going to put right here as F double prime. Then E. E is 1, 2, 3, 4 units to the mirror line. And so it's gonna go, let's put it back. 1, 2, 3, 4 units to the mirror line. So it's gonna go 1, 2, 3, 4 units to here on the other side. Down to negative 4. Alright, so it's coming down to here. That's where E double prime is. I know that you have the 3 points in place. You draw your triangle. Simple as that. E double prime, E double prime. That's it. That's the image after reflecting in this x-axis, which is the line y equals 0. Are they okay with that?
Yes, sir.
Are they okay?
Yes, sir.
All right, good. Let's continue. Number 6. I was skipping over number 6. This is maps and scales. We're going to do this topic. We're going to do ratio. All right, we're going to actually do this topic, maps and scales, and so on. So that's coming up. That's going to be like a one-day class. And this now is what we're doing tomorrow. Circular measures. It's just ironic that's on this paper. We're doing this topic tomorrow on Monday. Circular measures. All right. So next time we'll be able to do that question. All right. So we're going to calculate area of square, area of shaded region, all those things. Right. Circular measures starting that in tomorrow's class. Tomorrow on Monday. All right. So let's go. This topic will come later on as well. It will come after the plane and solid geometry. All right, so this topic coming soon, which is statistics. Coming soon. So it'll be fun doing statistics. Fun, yes?
For the question that you just did, the transformation, right? So
yes?
It said the reflection on the triangle D prime, E prime, and F prime, sir. I thought the reflection would be on oh, thank you. I was just trying to look on something.
Right. So reflecting the prime one to get the double prime one. That's what it said.
Okay.
So it said. See, a reflection of the prime one. And I wanted us to draw the double prime one. All right. So we did it right. You good?
Yes.
All right, cool. All right, so we're skipping over these guys. I think the next time we come back, we'll be able to do this question up here. All right, statistics, not yet. We need a couple more weeks. All right, so we're going to be plane and solid geometry before statistics. All right, but it's coming very soon. It's a nice topic, And then this one now will come after, we do rates of change, like velocity time graph, distance time graph, and so on. This will come after that, which, is a one-day thing again, but these questions are very easy. I show you how you get the pattern formally and so on, right? It's a very easy topic. This is a makeup time topic in the exam, okay? I can finish this question like in 5 minutes or less. So it's going to be like a makeup time topic, all right? We're going to see that this is a very easy topic. All right, we're going to have fun doing that one as well. All right, so we're doing the 3 questions in section 2. So you see, the beauty about this is that we can do the 3 questions in section 2 based on where we are in the syllabus. Imagine that. The 3 questions in section 2 we are able to do. So it means that we have a lengthy period of revision for these topics in section 2. All right, so I like the fact that we can do the 3 questions in section 2 based on where we are in the syllabus in January, at the end of January. All right, let's go. One lastly for these 3 questions now. All right, so this question says the table below shows 2 pairs of values, x and y, where y varies inversely. There's an inverse variation. It's an inverse variation, and y is inversely proportional to x. So since y is inversely proportional to x, see here they want us to express y in terms of x and a constant. Inverse means k over. So the y is equal to k over the x. If it was directly, let's just remind ourselves, if it was a direct variation, then y be equal to k times x. But inverse is this one, k over. Direct is k times. All right? Question says must calculate the value of k. Not every question asks us for the value of k. But if you look at this formula, if you multiply the x over here, you see that the k is actually equal to x times y now. So the k will always be equal to the product of the x and the y. So look at these two, say already k is equal to 6. Right? As simple as that. And I give you another pair that we could use, this pair, which is 4 times 1.5 is still equal to 6. Right? But we see where k can be found. They always use a known pair of values to find the k, and they gave us 2 pairs. I'm going to be using this first one. Don't matter, I could use this one as well. So I'm saying that the k is equal to xy. Let me write it down here for this line now. The k is equal to xy. And so I'm going to be using the 3 times the 2. And so that is equal to 6. The k is equal to 6. Now that you know that k is equal to 6, you can put it up here on the formula. Or you can even put it here. So it becomes a case where the product is always equal to 6. So we can put this in a box as well. That xy is always equal to 6. That becomes the formula. This is now your relationship formula that you're going to use in this and this to find the value of A and the value of B. Because the product is always equal to 6. That's how we're going to do it. All right? Not complicated, guys. Not complicated. All right. So in the first pair here, the x is A and the y is 1.2. I'm plugging them in the formula. So x is A and the y is 1.2. We're plugging them in the formula. So we can say, therefore, A times 1.2 is equal to 6 in this formula. Right? And you divide by the 1.2. So A is equal to 6 over 1.2. What that work out to? That work out to 5. 60 over 12, so that's 5. And I multiply this by 10, I multiply this by 10, you get 60 over 12, which is 5. 5 is correct?
Yes, sir.
All right. Then I'm going to use the same formula for this pair, where x is 20 and y is b. So when x is 20, y is b. So you don't get a lot of space to do all of this work, guys. You have to be very efficient. So the product equals 6. So it means that 20b, if you put them here, product is equal to 6. You divide by the 20. So you get b equals 6 over 20, which is 3 over 10 or 0.3. That is it. So those are my answers. The b is 0.3 and the a is 5. Everybody go to that?
Yes,
But
sir.
okay? All right.
Yes, sir.
All right, good. Moving right along. Next part is a quadratic. A quadratic where they give you a graph. When they give you a graph, it's easier, okay? You can see everything on the graph. Question gives us this as our quadratic function, and they show the graph. You can see the y-axis intercept is 8. There's a cross the y-axis at 8. All right, and the a squared is positive, so it smiles. It smiles. And you can see your 2 roots here, so. And you can see a minimum point right here. That's x, t, y, t. That's 3, negative 1. But let's see what they're going to ask us. All right. Question says, use a graph to solve the equation. This equation. Remember, this is the quadratic equation, you know, guys. This quadratic equation will always give you the roots. That equation will lead to the roots of the quadratic function. Lead to the roots. What are the roots? The roots are the x values where the graph crosses the x-axis. Right there and there. Right? So I'm going to come here. I'm going to write these and tell exam that these are roots. That's a root. And that's a root. Because I have to show something that I use a graph, you know. The question says use a graph. So I tell him that this gives me the roots. And I'm telling him that these are the roots. So the x values that you get at those points. At this point, x equals 2. And the other one here, x equals 4. These are my roots. And that's my answer. X values of the graph crosses the y-axis is a solution for that equation. Gives you the roots. But I go to that. But okay?
Yes, sir.
All right. Next part wants us to write the coordinates of the minimum point. Minimum point clearly is this point right here. So I'm going to write it and say this one is my minimum point. And I can put the coordinates there as well. 3 is the x value, negative 1 is the y value. 3 -1. 3, -1. I like this question. I don't have to do any work. Everything's on a graph. So this is my xt and this is my yt, you know, x value turning point. So my minimum point, which is xt, yt, t means turning point, xt, yt is 3, -1. So this is my xt value 3, this is my yt value -1. So I know my xt and my yt value. Then I come down here now. Question says we have to write this in this format. Remember, instead of using this format, I like us to use the format where we use the minimum point or the turning point in it. So we're going to write this instead as a bracket x minus. So if you don't give us a plus, I'm using x minus the xt value squared plus the yt value. And it's good to use this format because we know the xt value and the yt value. The xt value from the graph is 3, and the yt value is -1. That's what we just got a while ago. Let's write this better. So we can plug the 3 here and plug the -1 there. No work needed. And the a is equal to 1, and a is the coefficient of x squared is equal to 1. So we can just write it. Question says write it. So you don't need to calculate anything, right? So it's going to write the a is 1, bracket, x minus 3 squared, and then the plus yt is -1. -1. Done, that's it. You have to calculate nothing. Get the 3 marks free. And I've shown the examiner how I got it. Not falling out of the sky, because I did call this xtyt, and I did write it back here, and I did write that this form is the same as this. I'm leaving all those things on my exam paper. So the examiner see how I get it. It cannot penalize it for advanced knowledge. And the question did say write it. You can just write it down. But let's say I didn't know it like that. I wanted to calculate it, right? Which is, to me, is a waste of time. So I'm going to put this to the side over here. I would have to calculate xt. Let's do it this way now. I have to calculate xt to go here and yt to go there. So remember now, xt is minus b over 2a. If this is a standard form, then the a is equal to 1, the b is equal to -6. Let's shift this up a bit. And the c is a constant term out here, 8. So if I'm doing this, it will become minus b. This minus is this minus. The b itself is this -6. So I'll get -6. Minus a -6. So come a positives. Over 2a. 2 times 1. This minus is a plus. So that's like a plus 6 divided by 2. See, I get the same 3. Same 3. And the same 3 is coming here, which is what I have here. All right. And then the yt now, and the yt is easier to find when the xt is a whole number. That means that you can just plug that xt value in the function, plug it in the expression to get the yt value. You don't have to use a formula method to do it. So I'm going to put the 3 inside here. So that becomes 3 squared minus 6 times 3 plus 8. 3 squared is 9, minus 6 3 is 18, plus 8. This works out to -1 now, because this one is given -10. 9 minus 10 is -1, so it's a -1. See, the -1 is my yt value, same value about here, which is what I had here. Let's see, everything is consistent. But why do it this way now? When they give us the graph, I can see everything. I would do it this way in the exam. No, I would do it this way in the exam. Just write it down, because I have the data, I have the figure, I have the information. When you have the graph, you can look at the graph and know your stuff. All right, so this would be the preferred way for me in the exam room for the 3 marks. But I'm giving them this information, making sure I give them that, making sure I give them that, so they see where my figures come from. All right. Next part now says, on the same axis, draw the graph of g of x equals x minus 1. So this is like, let's put this in purple. I can put it in red still. This is like a line, y equals x minus 2, you know, no, x minus 1, x minus 2. So we draw a line, y equals x minus 2. What do we know about this line? We're going to do it the easy way. The gradient is 1, y-axis intercept. That gradient is 1, sorry, coefficient of x. And the y-axis intercept is negative 2. C is negative 2. All right? So we can draw this line easy. It passes y-axis at negative 2 and enters the gradient of 1. What gradient of 1 mean? Whatever you rise around the same amount. Rise around is the same value. Rise around is the same value. Let's start at this point, the y-axis intercept of negative 2. So it pass through negative 2 right here, so. And a rise 2, run 2. So this is the rise of 2, you know. But run of 2, we're going to take you over to 2. You can just go in coordinates, you know, because look at the horizontal scale and the vertical scale different. The vertical scale is 1 unit to 1 centimeter. The horizontal scale is 2 units to 1 centimeter. So you have to be careful. So I'm rising 2 units. The 1 is same as 2 over 2, for example. So I'm rising 2 units here and running 2 units there. So you're passing through that point. Right? So we're passing through this point. We can rise 2, run 2 again. Rise 2 more. And run 2 more. So from 4, if you run 2, you go from 2, if you run 2, you're going over to 4. So coming over to here. So that's another point. And they can rise again, rise 2, run 2 again. So if you rise 2 from 2, we're going to go up to 4 right here. 2, go up to 4 right here. And then from 4, if you run 2, we're going to come over to 6. To here. So those are points on that line that we want. All right. So use a ruler and you draw it, right? Use a ruler and you draw it. So this is g of x, the line. And I'm sure they're going to ask us a question about these 2 points of intersection. This one and this one. Most. That's the purpose of doing this. They're going to ask you something relating to the points of intersection. So this point of intersection is the point 2, 0. You can see it is 2, 0. This point of intersection is a point 5. Right here says 3, 5, 3. 5, 3. So the points where they intersect, the x value is 2 and 5. And the y value is 0 and 3. That's what they want us to do. But this is my line. This is my line. But I'm sure they're going to ask us about these. Most. Once you see a question like this, that's the purpose of it. But let's see. So we draw the graph. We draw the graph, right? So we'll go with that one. See? Hence, solve this equation. This equals this. Now you've realized now that this is a curve equals this is a line. So where the curve equal to the line is at the points of intersection on the graph. And because this is an equation in x alone, the answer must be x. So they intersect at the points, which will show the curve equal the line at the points. We did 2, 0 and 5, 3. Those are the points. But because this equation is in x, the solution of it will be a solution with x values. So plucking out these 2 x values for the answer. So it's x equals 2 and x equals 5. Now they don't want you to solve this, you know, because the question only said hence. So you can't go solve this any other way and get the answer. You have to get it from the graph. You get me? Because it only said hence. So they tell you to draw the graph and hence solve this. So they don't want you to work this out and solve, because if you work this out and solve it, you're going to get the same two values. But the question only said hence. If that said hence or otherwise, then it could maybe solve that equation and get the answers, and they would be the same. 2 and 5. But that is it. These are my answers right here. What good at that? Those are the x values where they mean.
Yes, sir.
Yes.
All right, good. Next question. What time is it? All right, can finish this by 11:15. Bam, we are able to do our circle theory now. We're just finishing this topic. All right, we're just finishing this topic. Whoa, you know I was supposed to work through the classwork today. I'm gonna do it now. I'm gonna go through the classwork. It's very easy. I'm gonna go through the classwork before I finish. Yep, I'm supposed to go through the classwork. Sorry about that. I should have started with the classwork actually. Let's finish this. A good thing I came up on this question to remind me. Because tomorrow's class, I'm coming straight and starting the new topics. I'm going to go through classwork from today. This question says, diagram below not drawn to scale shows a circle center O, and the vertices H, J, K, and L are of a quadrilateral line on the circumference. So this is a quadrilateral. So it means that it is cyclic. That is cyclic. It says PKM is a tangent at a point K. So this is a tangent at this point K. And we can see that. And then the measure of angle HJL is 20 degrees right here. And the angle of JKH is 50 right here. JKH right here is 50. So everything that they have set up here, we can see on the diagram. So we don't have to read up here again. Anything we want, we can go to the diagram. Question says, calculate given reasons for the steps in the answer. So these are the rules. You cannot just write on the answer to say why. And the main reason most of the time is the 7 circle theory rules. All right, now let's go. First angle they want, let's put it in red, is angle HKL. HKL. That's this angle up here. All right. So to find that angle up there, I need to find a chord. So what I do, I go back along the lines that form the angle. Go back along that one, this point on the circumference. Go back along this one to this point on the circumference. And I realize that this is a chord that is subtending that angle, or the arc. But usually once it's that chord, we work with the chord. What is the chord doing? The same chord is subtending this angle up here, which is 20 degrees. So the same chord is subtending another angle on the circumference in the same segment. So that's the same segment rule. So since this angle is 20, subtended by this chord, the same chord subtends the same angle up here. So this angle up here is also 20 degrees. Same segment rule. All right, so let's write that. This angle is equal to 20 degrees. Reason, angles in same segment. Angles in the same segment are equal. You can stop there, so we can continue and say when subtended by the same chord or arc. That's the reason. Angles in the same segment are equal when subtended by the same chord or arc. But if you write just this up to here, so just that, they will give you a marks. Angles in the same segment are equal. If you write that, I'm sure you get your marks. All right, well, let's continue. So let's erase these and put on the 20 degrees. So know that this angle up here is 20 degrees right here. It's 20 degrees. So that better. This is 20 degrees. 20 degrees right here. All right, so these two angles are subtended by the same chord. All right, next part wants us to get JOK. Who is the center now? So now we're going to use center rule. So that's right here, JOK. All right, so let's look at it. We want this angle now. Now, that angle is at the center, right? But first thing I'm going to tell you is that that's an angle in this triangle. That triangle is isosceles. Why is it isosceles? But this is a radius, this side is a radius, and this side is a radius. That's a radius and that's a radius. And once you know one angle in an isosceles triangle, you're blessed. You can find the rest of them. So that triangle is isosceles. This angle is equal to 50. And it is opposite this side. And so the one that is opposite this radius, so one angle opposite this radius is 50. So the angle opposite this other radius is also 50. So this angle over here is also 50. And remember now, total angle in the triangle is 180 degrees. You know? So if these two add up to 100, then the one in here that you don't have right now must be 80. All right? So let's fill it out now. Make the pen a little smaller. Right. So this is isosceles as we have said. So this angle and that angle is the same. So I'm going to put it on the diagram. Over here is 50 degrees. I'm going to call these two add up to 100. The total angle triangle is 180. This must be 80 degrees. I'm going to use that for this question. Let's tell the examiner. Total angle in isosceles triangle is 180 degrees. So let's write it. I'm going to tell him first that that triangle is isosceles. Angle JOK. Triangle JOK is isosceles. Triangle JOK is isosceles. So the angle down here is 50 degrees. So angle KJO is 50 degrees as well. So angle JKO is also 50 degrees. Therefore, the angle that I want, angle JOK, is 180 degrees minus 2 times 50 degrees, which is 80 degrees. Because total angle in the triangle is 180. Total angle in the triangle is 180 degrees. That's it. Total angle in the triangle is 180 degrees. That's our reason. I did say it is isosceles. Why? Two angles are the same. Two angles equal, right? 50 degrees. Next part wants angle JHK. Let's see where that is. JHK. JHK. That's this angle the one, no, that angle. All right, we're gonna get that angle. All right, so that angle I can say is subtended well. That's a right angle triangle, you know. Over here says 90 degrees. One is 90 degrees. It's subtended by this diameter. We can find another way. So I can tell you right now, since this is 90, and here says 50, then up here says 40. Because these two angles are complementary. We can find another way using the center rule. I'm sure you're going to use the center rule for it. Because this angle up here that we want now, if you come back and find a chord, it is subtended by this chord. Let's come back. So that angle up there that we want is subtended by this red chord. It is the same chord that is subtending the 80 degrees at the center. So the angle at the center is twice the angle at the circumference. That's why up here says 40 degrees. Because angle at the center is twice angle at the circumference. So I can put that angle here as 40 degrees, half of this. So this angle is 40 degrees up here that I want. I'm going to use the center rule for this one, easier. Angle at center is twice angle at circumference. So down here, we're going to say this angle is half of the 80 degrees, which is 40 degrees. Because angle at center is twice angle at circumference. You can leave that. If you want to finish it, you can say when subtended by the same chord or arc. If you leave this on the exam paper up to here, angle center is twice angle circumference, I'm sure you'll get the marks if you just stop right there. All right, let's continue. Anything else? Oh, they're done. They don't want any more angle. All right, they're good with that. Let's continue right here. We still have 2 classwork questions to run through quickly. It's very easy. Not going to take a lot of time. The 2 classwork questions that we did. This question is a bearings question. Bearings question, obviously. So the outlines there. All right, let's see what it says. It says a ship travels from Akron, which is A right here, on a bearing of 0-30 degrees to B, to Belleville, to B. So from here to here, on a bearing of 0-30 degrees. So let's draw that 30 degrees. Let's put on the diagram right away. So like you're at A, and you face north first. You say angle choose to turn to the right to face B. So this angle is where the 30 degrees is, 0-30 degrees. So let's put it on the diagram. So this angle right here is 0-30 degrees, right here. Turning to the right. 0-30 degrees. 0-30 degrees. All right, that's that angle turning to the right. What else does it say? It says it is 90 kilometers away. So that's this distance, 90 kilometers. Let's put that on as well. So this distance is 90 kilometers. 90 kilometers is that distance. All right. It then travels to Compton, C. So from here now, it's traveling down to C. Right? They go to B first and then go here to C, which is 310 kilometers due east of A. So this point is 310 kilometers to the east of A. No, of A means from A. So C is 300 kilometers east. Now remember, east means towards the east. From A. From A. That's what I write, but that's what it means. So from A to C, it is 200 kilometers to the east. So we can see that it's talking about this distance here. So now, this is east. This way is east. So that way is east. Then right here says 90 degrees. Because remember, the bearing of east is 90 degrees. All right? And if this part of it is 30, then it means that the angle inside here is 60. And the distance is 310. So let's fill out the diagram. So this is 310 kilometers. And because this is east, then the whole of this angle here is 90. And then because this part is 30, then the angle inside the triangle here is 60 degrees. I'm filling out the information. I can find the side over here so now, using cosine because they have 2 sides and an angle between them. But that is the diagram based on what they have said. That's the diagram based on what they have said. All right? All right. Question says, Indicate on your diagram the bearing of 0 to 30 degrees. That's right here. We have it. The distance of 90, we have it. And the 310, we have it. Now, plenty people would make a mistake and put the 310 on this. You know. You have to read the question carefully. This will be wrong. Put the 310 on there. Read the question carefully. All right? Read the question carefully. A lot of people put the 310 in the wrong place. All right. So read the question carefully. It's 310 east of A. That's this distance. It's 310. Says now, calculate the nearest kilometer, the distance from B to C. That's this distance. So on, BC. All right. So we're going to use cosine rule because we have two sides. We have two sides and an angle between them. So we're going to use cosine rule. Tell examiner, cosine rule. Let's go back for the blue. Cosine rule for the BC. Remember, cosine rule start like Pythagoras' theorem. So BC squared is equal to this side squared plus that side squared. 90 squared plus 310 squared. When a Pythagoras' theorem says subtract a piece, you subtract 2 times the 90 times the 310 times the cosine of the angle between them. The angle between them is this 60 degrees here. Cosine of 60 degrees. But instead of putting the square on this, guys, I can leave off the square. I can leave off the square and put the square root over this instead. And I want us to actually practice it that way. And then just put everything here on the calculator. All right? Put everything there in the calculator and get the BC one time. And then set to the nearest kilometer. Let me bring up the calculator and do it. So, doing it here. First, I have to make sure the calculator is in degrees. If you look up here, the calculator is in RAD, meaning radians. I have to put it in degrees because I'm doing my calculation in degrees. I'm going to get it in degrees. See, it's now showing DEG at the top there, degrees. All right, you want to always make sure when you're going to do trigs, you have to make sure your calculator is in the unit that you're doing the trigs in. But CSEC, it is degrees. All right, ready now. So the square root of 90 squared plus 310 squared minus 2 times the 90 times the 310 times the cos of 60 degrees. Cos of 60 degrees is a half. Let's set to the nearest kilometer, so I'm going to write it 276. 276 kilometers. To the nearest kilometer means that you don't put a decimal on it. That is it. All right, that is that. But okay with that one?
Yes, sir.
Yes, sir.
All right, and as you find something, you put it on the diagram. Always put what you find on the diagram. It helps. So this side is now 276. 276 kilometers. So the only thing we don't know in this triangle are those two angles, which we can use sine rule for. Why? Because we have this pair now of angle and side opposite each other. We know both of them. So anything else we want now, we can use sine rule. I can use this side with this angle, or I can use this side to find that angle in the sine rule. All right. So just make a note of that. So put it on the diagram. Now they want us to calculate, you see, they want an angle to the nearest degree, angle ABC. Let's call it alpha and put on the diagram. Alpha, angle ABC, angle at B. Where's that? Now, actually I want this angle right here, so now, which I'm calling alpha. So you see, I put it here that I'm calling it alpha, and I show it on my diagram. So it's easier to reference it. Instead of saying angle ABC, so let's call it alpha. And as I've just said, I'm going to use sine rule. These two with these two. Sine rule. All right. So using sine rule for alpha. All right. Ready? So using sine rule. Tell examiner. Sine rule for the alpha. Start with what you want. Sine of alpha over the side opposite to the alpha is a 310. Equals sine of the angle that you know. The angle that we know is a 60. And the side opposite to it is at 276. That's why it's good to put on the diagram, right? So it's a sine of 60 degrees, put on the degrees over the 276. You want to find the alpha. Want to take the 310 and multiply it up here, and then take the inverse sine. We have to be able to do these things in one step. See, we don't have a lot of space to work with. Don't give us a lot of space. So I'm going to multiply with 310 first. We're going to get 310 sine of 60 degrees over the 276. That's going to leave with sine alpha initially. But I'm going to put the inverse sign on it. And that's going to make the alpha now equal sine to the minus 1 of this. So you don't have a lot of space. You have to be able to go from this to that. Practice, you'll be able to do it every time, quick and fast. With practice. All right? You have to practice and skip out some of the steps that are unnecessary. So I'm going to work this out now. So it's sine to the minus 1 of a fraction. It's 310 sine of 60, which is 0.866 or root over 2. But I'm going to write sine of 60 here. Sine of 60. And I'm dividing that by the 276. Calculator giving me 76.5. But because I said to the nearest degree, I'm just going to write 77 degrees. So alpha is 77 degrees. I'm going to put it on the diagram. 77. So I'm going to come up here. I'm going to put the 77 degrees right here. 77 degrees. As I would have written the alpha. So I'm going to write the 77 degrees now. That angle 77 degrees. No, we don't get this bearing yet, you know. But let's see. I think they ask for that next. All right. See, determine the bearing of C from B. Now remember, I must always note the from position. So it's actually from B to C. Go on. Always note the from position. The bearing is done at the from position. All right. So we're going to draw it on the diagram. What that angle is, and we're going to call it theta on our diagram. Do the same way every time. And then work out how we're going to get the theta. All right? All right, let's go. So from B to C. So this is the B down to C. So the bearing that we want, let's draw it. Let's put down in purple. It stand out. So like a standard is from position B, face north first. Angle through which have to turn to the right in order to face C. So it's this angle that we want right here. Let's draw it in. We want this angle right here. So now, this angle is the theta that we want. This is the angle, bearing angle that we want, theta. So I call it theta and I show it on the diagram. Right? I call it theta in the working and I show it on the diagram. So I'm trying to find out that angle. But this is very easy, you know, because look here. The total angle around this point is 360. Inside here says 77. Watch this now. You have co-interior angles here. This line parallel, this line parallel. So you see a U. Remember angles in the base of U, this and this one, they add up to 180, these two. They are called co-interior angles, they add up to 180. So because this one is 30, then this one up here must be 150. This angle right here must be 150. So this is 180 degrees minus 30 degrees, which is 150 degrees. That's this angle. It's 150. So to find this theta, it's just 360 minus the sum of these two. 360 minus the sum of those two gives you this angle that we want. 360 minus the sum of those two. So we can say this theta equals 360 minus 150 and also the 77. I want to show you another way to do it. More mass equals better mass. And see that we get the same answer. Let's work it out. So it's 360 minus the 150 and also minus the 77. That's 133. 133 degrees. All right? That's one way to do it. That's one way to do it. Let me erase these and show you another way. So it's 133, you know. All right, let me copy it down here, so. Let me copy it down here, so. So based on our diagram, we are saying the theta will be 360 minus the sum of the 150 degrees in the U angle and the 77 degrees. Our total angle around the point is 360, so that's 133 degrees. All right, I would maybe leave that, right? But let me show you another way still. More maths equals better maths. Let's see. All right, so we want that purple angle. We want that purple angle. Let's look at it closely. And we know that this angle inside is 77. But watch this now. This line that I'm going to draw, this line, AB, it is forever and ever amen and a bearing of 30 degrees, you know. So if I take this line and I extend it out like this, the bearing from here to here is still 30 degrees, you know, right here, so. It's still 30 degrees. Right? Right, this is 30 degrees, you know. And then the remaining part here says a straight line. From here to here is a straight line. 180. Remember the purple angle I want, you know. So if I can find this piece right here, so I can add it to the 30 and get my bearing. So I'm showing you now that this is a straight line 180 from here to here. A part of that 180 is this 77. So if I want this other piece right here, it will be 180 minus 77. 180 minus 77. What that work out to? That work out to 103. 180 minus 77. 103. So this angle right here, so, is 103. 103 degrees. So you see that the purple angle now, which is a theta, from all of this, the purple angle theta will be 30 degrees up here, so plus the 103. That's another way to do it. 30 degrees plus the 103 degrees, which is the 133 degrees. What maybe I think most persons would have done it the previous way, the way that I did it first, right? Which is this way. I think most persons would do it this way, but I still want you to understand that a line, this line or this direction is 30 degrees everywhere on it. The bearing of this line is 30 degrees. Even down here, we put a knot line here, this is still 30 degrees. 0, 30 degrees, just the same everywhere. All right, so we can use that sometimes to do some other questions. All right, but that is it. Anyway, take it, the bearing is 133 degrees. All right, so that is that. So I showed you 2 ways. That is that for this question. Question done. Bearing is 133 degrees. Then we'll come to the last one, which is this one. I did say 11:15. Like a bit longer time on that one a while ago, but that's fine. Let's do this one quickly then. Don't need a calculator. I'm still gonna do the 2 questions on my classwork, you know, guys. I'm gonna do it because I'm not coming back on them tomorrow. All right, I'm gonna do it on before we finish. Question give us this matrix, and it says it maps this point onto that point. So that's a transformation matrix, right? So basically then, when you multiply this point by this matrix, it is equal to that one. So like we're setting up an equality of matrices. They want us to get the value of A and B, C and D, sorry. So let's go for the blue. So like you set up this times this. So it's COOD times this point, which is 2, 3, is equal to this point, which is 2, -3. So we have what we call an equality of matrices situation. Remember now that it is the rows of the first matrix times the column that it gives you these values. So from here, for example, it is this row times this column that is equal to this. sorry about that. All right. So this row times this column gives us this value 2. So we can set up an equation based on that. So it's a C times 2 and the 0 times 3, that is equal to 2. So the C times 2 is 2C, plus the 0 times 3 is 0. That is equal to this 2. So you see that the C is equal to 1 based on this. C is equal to 1. And then this -3 is a product of this row and this column. So then, again, you can say it is 0 times 2, and it's 0 times 2, and the D times 3, that is equal to this -3. So we can set up that again. The 0 times 2 is 0, and the D times 3 is 3D. That is equal to this -3. So again, you're going to see now that the D equals -1. So those are my values, my answer. Let me underline them in blue. This and this. So based on that, I can write what my matrix is in. I know my matrix now. So I can put it over here. Let me put it over here in purple so it stands out. My matrix T, because I want to see so I can know what it is. The C is 1, 0, 0. The D is -1. This is the x-axis reflection matrix in a guy, reflected by the x-axis. X-axis reflection. So that is it. That's the x-axis reflection, reflecting over the x-axis. It said determine the image of this under transformation T. You can look at all the values change, you know. So the x value comes back unchanged, but the y value changes sign. So all you have to do the same thing with this. This point, -5, 4. Under transformation T, I don't have to calculate. No, just look how the values change. The x value is not changed. It comes back in the same position, same value. But the y value changes sign. So the 4 is going to become -4. Simple as that. This is a very easy topic. Anything the T does to one point, it does the same thing to all the other points. All right, but if you wanted to spend more time on it, they could multiply this matrix by this point. But it don't make sense. You have to learn to do the mathematics the easy way. This is the answer right here. All right. Next question. Describe T fully. You can describe it fully if you know the matrix. That's a reflection in the x-axis. A reflection in the x-axis. Done. A reflection, you just need to stay at the mirror line. That's it. Reflection in the x-axis. Done. 2 marks for that. So it's easier when you know the matrix, guys. Right? You don't have to go figure it out. Some persons have to put these points on a sketch to see what happened. We don't want to have to do that when you can just learn the matrix. The more things you know, the better. All right. Next part says, find a matrix which maps Q back onto P. Look here. The inverse of a reflection is the same reflection. You know? If I have a mirror line, this is the point that maps Q back onto P. Hold on. Right. So this was P to Q, right? Reflected x-axis. Good. So if you have a point up here, P, and you reflect it in the x-axis to Q, and you want to go from Q back to P, you have to reflect it back in the same line. So it's the inverse. The inverse of reflection is the same reflection. So T, I would say that I would say it this way. T, the inverse of T I want to know. So I would say something like this. The inverse of T will map Q back to Q, bam, back to P. So I said T to the -1 is equal to T. Remember the transformation is T, you know. T is a matrix, right? T. Inverse of a transformation of a reflection is the same reflection. So this will give out the same matrix. 0, no. 1, 0, 0, -1. That is the answer. I'm not going to do it any other way. Reflection of a reflection is the same reflection. The more things you know, the better. The inverse of a reflection in a line is to reflect back in the same line. And this is a reflection this is the matrix for reflecting in the x-axis. But if you want to calculate it, you want to get this to the If you want the 1 over the determinant of T times T adjoint, if you want to work it out, you're going to get the same matrix. But I don't have to work that out. Things that you can know them. Know them. The inverse of a reflection in a line is to reflect in the same line that I just showed you. if you have the point P and this is the x-axis, and you reflect it down to Q, and you want to go from Q back up to P, you have to reflect it back in the same line. Right? The matrix for reflecting in this line, whichever direction they're going, is the same matrix. This one. So that is the matrix, same matrix. Right? So students who get straight A's and top the cabin are people who can actually do this quickly because they know and they don't have to waste and work it out and get the 2 marks easily. By just doing that, that t to the minus 1 is equal to t. That's showing that you know that the reflection in a line, the inverse of a reflection in a line is a reflection in the same line. You need to know the inverse of all transformations. Know the simple way. The inverse of a rotation is a rotation in the opposite direction, same angle, same center. The inverse of an enlargement, for example, of scale factor 2 about a center is an enlargement of scale factor half with the same center. Right? The inverse of a translation is just basically go the opposite direction. So you put in a minus. So if you do a translation 3 units to the right, you can go 3 units to the left. Simple. So they're not difficult. The inverse of a reflection is to reflect back in the same line. You reflect the image back in the same line and take it back to the object. Much not saying anything more on that. We'll come to this part B now. It says the graph below shows points P, Q, and R relative to O. All right, so they give us these points. P, Q, R relative to the origin, O. All right. Everybody there? Just looking at like a quick check. I haven't heard from you in a while. Everybody's there?
Yes, sir. Yes, sir.
Okay. Because I was just wondering.
Yes, sir.
All right, good. I can see the screen good and everything, just the same.
Yes, sir.
All right. Hold on a second. All right, good. Still recording. Just do a little quick check. I mean, sometimes I can't trust the technology, you know. All right. So, right. So give us these points relative to O. So this is like the vector. This is the vectors question, right? See, write down the column vector for OP. Now watch this. Remember, I know this is the point P. P has coordinates 4, -1. So the position vector is gonna have the same value written in vector form. See, x, y, same way. So basically, just have to write this. This becomes 4, -1. 4, -1. It's not complicated. All right. The number one QR. Now I can look at the diagram and know what QR is. You know, because QR is how you go from Q to R, like translation. That's what the vector is. You know. So if I look at the diagram, how do I go from Q to R? I go this number of units to the right. How many units? That 3 units, and this number of units upwards. How much units that? From 2 up to 7, that's 5. So I can tell you that this is 3, 5, 3, 5, you know. 3, 5. Can tell you by looking at the diagram, because to go from Q to R, I go 3 units to the right, and then I go 5 units upwards. See, 1, 2, 3, 4, 5. Like this. Well, let's say they wanted to calculate it. So I know the answer is this, you know. I'm in the exam and I'm pressed for time. I'm going to put this on the diagram and show them. I don't need to calculate it. That's what I love about diagrams. The answer is there on the diagram. But if you want to calculate it, then we would maybe use something like O times the last minus O times the first. Right? R is the last, Q is the first. O times the last minus O times the first. Now, what is OR? R is a point, what is it? 3, 7. R is a point 3, 7. Let's write it 3, 7. R is a point 3, 7. So 3, 7 minus OQ. No, Q is a point 0, 2 right there. 0, 2. 0, 2. And if you work this out, you're going to get the same 3, 5 that I just showed you. And if I'm in the exam room, I'm not going to do this, when I have the diagram, I'm going to draw it on the diagram and show it. This way, that way, 3 units, 5 units, and you will see where I got my vector from. All right? A vector is where you go from one point to another point. The horizontal movement first, then the vertical movement. Just like translation. Topics are related. All right? Then I come down here now. What else they want? They want the magnitude of QR. The magnitude is just the length of this line. How long is this line? The QR line. So can use Pythagoras' theorem. Because this is a right angle triangle. This side is 3, this side is 5. So Pythagoras' theorem said that this length will be the square root of 3 squared plus 5 squared. Let us use normal trigonometry. But then if using the vectors formula method, it's the same thing you're gonna get, because since the vector is 3, 5 here, then using the same coordinates or the components, then the modulus or magnitude of QR, which is the same as the length of the line, is the square root of this value squared plus this value squared. 3 squared plus 5 squared. I don't have to work it out fully, This is 25 and this is 9. 25 and 9 is 34. I'm going to write square root of 34 and put units. I don't have to work this out fully. I can leave it like that. It's okay to leave it like that. All right? That is it. Then now I come down here and it says, on the graph provided on page, draw the vector OS. So OS is 7, 4. That means that S is a point 7, 4 now with the same values. Because OS is a position vector of S. So S would have the same coordinates, same values, 7, 4. So I'm going to put this point on the diagram and see what is happening. So I can see what is happening, right? So S is a point 7, 4. Let's look at it. 7, 4 is right here. 7, 4. Talking about this point. Right? 7 across, 4 up to here. That's where S is. Right? Let's put it on there. S is this point. All right. This is the point 7, 4, S. So this vector is OS. This is the vector OS across here. That's the vector. If I ask you to show the vector OS, that is the line you have to draw. All right, let's see what I want us to do. They said on the graph provided, it must draw the vector OS. So you see, you have to draw that line, You can't just put on the point. You have to draw the vector OS and then show that PQRS is a parallelogram. All right, let's do this first and then talk about how you show that that's a parallelogram. All right, so let's do this first. Draw the vector OS. So you have to draw the straight line, guys, from O to S as a vector OS. So you can't just put on the point S. So you draw a straight line across there like that with your ruler. So you can draw it better. Straight across there. Use your ruler and draw it. Don't draw it freehand like me. All right, draw it with a straight line and put the arrow on it and put the OS on it like the examiner see. That's the vector OS. And then now they want us to show that this thing is a parallelogram. Right? This thing. PQRS. See? PQRS is a parallelogram. I'm going to draw it out in red. QRS. So we show that this is a parallelogram. And what do we know about a parallelogram? The opposite sides are equal vectors. So to show that that is a parallelogram, we need to show that what are the vectors that we have? Can it make sense to use some of the vectors that we have already? So what are some of the vectors that we have? We have QR, for example, right? So it makes sense to use a QR. So QR is this vector over here. we need to show that this vector over here is equal to this one, PS. PS, right? And which other vector that we have? We can use these two. So we can use SR and PQ. All right, so we need to also show that this vector over here is equal to this vector over here. All right, so we need to show the parallelogram. We have to show that this happens. We have to show. I was writing it here and I'll copy it down. We have to show that PS is equal to QR. PS is equal to QR, and also that PQ is equal to SR, or SR is equal to PQ. SR is equal to PQ. Those are the things we have to show for it to be a parallelogram. Let me copy this down now. That's what you have to show. If it's a parallelogram, you have to prove that that is true. And paste it here. That's what you have to show. To show that this is a parallelogram, you have to show these two things. All right, let me move this up here now. All right, so we need to work out what we don't have. All right, so I already have QR, right? QR was 3.5. Where is it? 3.5. So we have that already. So QR is 3.5. So we need to work out PS and show say equal to Q 3.5. So I want to work out PS now. PS would be OS minus OP. O on the last minus O on the first. And the OS is 7.4 minus the OP. What was the OP again? The OP was 4 negative 1. 4 negative 1. 4 negative 1. And so when you do 7 minus 4, you get in the 3. And with a 4 and minus a negative 1. 4 minus a negative 1 is 4 plus 1 is 5. So you get in the same thing that QR is. So this is equal to QR. So you have shown right here that PS is equal to QR. So you can tick off condition 1. Second thing you have to show is this now. SR is equal to PQ, but we didn't work out PQ yet. So we might have to work out both of them. So SR is equal to OR minus OS. And the OR is what again? The OR was 3.7. At the point was 3.7, right? Up here. OR is 3.7. 3.7. So this is 3.7. 3.7 minus the OS is 7.4. 7.4. So this one works out to be 3 minus 7 is negative 4. 7 minus 4 is 3. This is SR. And I want to work out the PQ right beside it and show that it is the same. So the PQ now is OQ minus OP. The OQ is 0.2. And the OP is 4 negative 1. So if we work this out, we're going to get 0 minus 4, which is negative 4. And then 2 minus a negative 1. 2 minus is a plus, to get 3. And so the two of them equal the same thing. And you can therefore conclude that SR indeed is equal to your PQ. This is a PQ. And so you have shown the second condition. You have to tell the examiner this, you know. They need to show these, you know. So we can say yes and yes. Showing both of them right here. And so we can write the conclusion. Therefore, PQRS is a parallelogram. And that's it. PQR is a parallelogram. If you write a little bit neater than me, but I don't have a lot of space to work, but you know, you have to learn to be efficient in the space that you're given. All right, but that finishes this. But let me jump over to the classwork now, guys. How we did. Because I'm not going to finish before we do that one, because I'm not coming back onto it. Moving on to a new topic. Moving on to a new topic. New topic tomorrow. So let's just look at that classwork. It was right here. Where is it? Classwork 1. All right, this is it. Let's split the screen. Bring up a blank page. Very easy to explain this one. Very easy. That's gonna take not gonna take any time. Not gonna take any time to explain. Just run over. It's very easy. Super easy. I think everybody would have gotten it right in the class eventually. All right, so this question gave us this diagram. Number 1, it's not drawn to scale, guys, so you can't go by on it or how anything looks. So for example, this look at diameter, you cannot assume it's a diameter because they did not show us the center. And you also cannot assume that this is 90 degrees, because I don't. But if I look like a 90, you can't assume it. And you can't assume that this is a 90 either over here, because it might look like a 90. You cannot go by how anything looks. You can't assume that this line divides the triangles equally. No, don't assume anything by how it looks, because bold letters here says not drawn to scale. All right. So they tell us though that these two sides are equal in length. That's this and this. So it means then that we have an isosceles triangle. And if this is an isosceles triangle, then the angle opposite this side here is equal to the angle opposite this side here. So those are your two equal angles. Some persons were not getting the equal angles correct. Those are the two angles that are equal, those two that are marked in blue. All right? And they gave us this angle right here as 27. And we see it's the angle between a tangent and a chord. So the tangent and chord will come into play in this question. First angle we are to find was angle KLN. That is this angle over here, KLN. Right here, KLN, this angle. All right, so we're trying to find this angle right here. That I always say, if I can't see it right away, go back along the sides or the lines forming the angle and locate the chord or the arc. This is a chord that is subtending that blue angle. What is it doing? It's making an angle with the tangent. So the tangent and chord rule comes into play. So since the angle between the tangent and the chord is 24 degrees here, then the chord subtends the same 24 degrees at the circumference up there. That's the tangent and chord rule. They also call it alternate segment rule, because it's in the alternate segment. Angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment. So this angle is 24 degrees. All right? And the reason is because of what I just said, tangent and chord rule. So let's write it. This is 24 degrees. And because the triangle is isosceles, it means that this angle is 24 as well. I'm just going to put it on from now. 24. All right, and the reason for that is the tangent and chord rule. So part 1, angle KLN is 24 degrees. Why? Because the angle between a tangent and a chord equals angle subtended by the chord. That is sufficient. If you want to go on, you could say at the circumference in the alternate segment of the circle. But usually, if you just write this, you get your marks. That is sufficient. All right. So that's what we have so far. This is 24. Next part wants us to find NKL. That is this angle. This is an isosceles triangle. And once you know one angle in an isosceles triangle, you're blessed. This angle here, you know that we want is 180 minus the sum of these two isosceles triangles. So part 2, very easy. Angle NKL becomes 180 degrees minus the 2 times 24 degrees. And that gives us 132 degrees. But this is 48. So this angle is 132. Right here. 132 degrees. This angle. All right. What's the reason for that? The triangle, total angle in the triangle is 180. Total angle in the isosceles. That's why we have the 2 times 24 because it's isosceles. That's right. That isosceles triangle is 180 degrees. That's why we subtract from 180. All right, and that's the reason. Then we'll come to part 3. This is find angle LMN, which is the angle across here now. So we're now trying to find this angle. Let's look at it. Now, this thing is a cyclic quadrilateral. It's the first thing that jumps out at me. And so these two angles, they are opposite each other. They are supplementary. You can find it that way. So this angle over here will be 180 minus 132, which is 48. But another way we can find it, so that's one way. That's the way that most persons would use. But the other way that we can find, let's do it in purple or in blue, is to say that this angle that we want, if we trace it back, to find what is subtending it, this angle is being subtended by this purple chord. And that purple chord is making contact with the tangent at the point of contact, at the point of tangency. And the angle between the chord and the tangent is over here. 24 plus 24, which is 48 degrees. So the angle between the tangent and the chord is 48 degrees, because of the 24 plus 24. So the chord will subtend the same 48 degrees at the circumference over here. So that's two ways to find it. So whichever way you prefer, the angle is 48 degrees. Let's say I'm going to just use a cyclic quadrilateral. And so the angle LMN is 180 degrees minus the 132 across from it in the cyclic quadrilateral, which gives me the 48. But you could have used tangent and chord rule as well, where NL would be your chord in this instant. Right? 48 degrees with a tangent. So that's another way we could have gotten it. Let's write the rule that we use, cyclic quadrilateral rule. And this is because opposite. A lot of persons leaving off the word opposite. Opposite angles in the cyclic quad. Quad means quadrilateral. Are supplementary. Supplementary. And supplementary means that they add to 180 degrees. Right? And we did say that this thing is a cyclic quadrilateral. That's the reason that we use it. But we could have used a tangent and chord, as I've said. All right. So these two angles across from each other are supplementary in that cyclic quad across here. So since this is 132, this one over here is 180 minus 132. They add to 180 degrees. All right, that's the reason we use. But as I said, we could have used a tangent and chord that I just showed you. All right, that finishes that first question. Then we'll come to the second question, which was this two tangents question. Two tangents of a single external point. All right, two tangents of a single external point. Let's look at it. It said the diagram not drawn to scale shows a circle center O. EA and EB are tangents. So that's two tangents of a single external point out here. The two tangents, they're going to be equal in length, as you know. And the angle between those two tangents is 48 degrees down here. All right. It says calculate given reasons first to the angle OAE. O to A to E. That's this angle right here. That's a radius and that's a tangent. Angle between a radius and a tangent is 90 degrees at the point of tangency. You must know those things. You must know that angle between a tangent and a radius is 90 degrees. So right here is 90 degrees. Down here also is 90 degrees. Tangent and radius, same thing. So let's go for number 2. Let's go for number 2. So the first angle I want in number 2 is angle OAE. That's 90 degrees. Reason, angle between tangent and radius is 90 degrees. Done. If you want to say at the point of contact, so on, that's it. But if you write this, I'm certainly going to get your marks. Next angle I want is angle AOB. That's right here. Now, everybody must know that two tangents together with the two radii in the circle, two tangents from a single external point, together with the two radii in the circle, it becomes a cyclic quadrilateral because these two 90-degree angles opposite each other, they add up to 180 degrees. And because the total angle inside the quadrilateral is 360, that means that these two must also add up to 180 degrees. And so it's a cyclic quadrilateral. And so this angle down here must be 180 minus the 48. So it's going to write that. The angle that they want, which is angle AOB, has to be 180 degrees minus the 48 degrees. That is 132 degrees. Why? I'm going to tell the examiner that this thing is a cyclic quadrilateral. I'm going to tell him that AOBE is a cyclic quad opposite the cyclic quad. And then now, why am I subtract from 180? I tell you what happened in the cyclic quad. Opposite angles. Opposite angles are supplementary. So I'm telling him that this is a cyclic quad. It's always a cyclic quad. The two tangents and the two radii. That's knowledge. The more things you know, the better. Two tangents from a single external point together with the two radii inside the circle will always form a cyclic quadrilateral. Always. And the opposite angles are supplementary. So if you know this one, you know this one. All right, so let's put them on back. So this one over here is 132 at the center here. 132 degrees, this angle. 132. The next part asking us for angle ACB. ACB. That's the angle up here. Watch this now. Always, if you can't see it, find what is subtending the angle. An angle is subtended either by an arc or by a chord. So I'm going to come back along the lines forming the angle to the circumference. And I see that it's this arc around here. Let me draw it in a different color. It's this arc around here that is subtended. It is the blue. That is subtending that angle at the circumference. This arc around here. Now the same arc is what is subtending this 132 degrees at the center. That same blue arc. So we'll go for the center rule. Angle at the center is twice angle at the circumference when they are subtended by the same arc or by the same chord. So the one at the circumference must be half the one at the center, and the one at the center is twice. So this angle is half of the 132. Simple as that. So we're going to for the next part 3, is that the angle that we want at the circumference ACB is equal to half of the 132, which is 66. Because the one at the one at the center is twice. It's going to write no reason angle at center is twice angle at circumference. When they are subtended by the same arc or subtended by the same chord. This time they are subtended by the same arc. If you want to write that, you can write it, but if you leave that, they give it the marks. Just the same. Angle at center is twice angle at circumference. They'll give it the marks. And the last thing I want here before this explanation is angle ADB. So let's zoom up the diagram again. Let me erase these. Now what we just found, which is the 66 degrees right here. And now they're asking us for this angle right here. Put it on in blue. Now plenty persons work this out as 180 minus this. But plenty persons work as if this is a cyclic quadrilateral. It's a quadrilateral, but it is not cyclic. Why is it not cyclic? Because only 3 other vertices are on the circumference of this circle. This vertex is not on the circumference. So you cannot use a cyclic quadrilateral rule in that quadrilateral. Right? You don't know that it is cyclic because this is not on the circumference of a circle. 3 points are on, but not this one. The cyclic quadrilateral in this diagram is actually this one. The 4 vertices are on the circumference. So that one is cyclic. So it means that this angle that we want now is supplementary with that one. These two add up to 180 degrees. Those are the opposite angles in the cyclic quadrilateral. So this angle here now comes 180 degrees minus the 66 degrees, which is 114 degrees. Let's do it over here, part 4. The angle that we want, which is angle ADB, becomes 180 degrees minus the 66 across from it in the quadrilateral, 114 degrees. And I write the same reason. Opposite, I have to put the word opposite, remember, opposite angles in the cyclic quad are supplementary. Supplementary means that they add to 180 degrees. That's why that angle is 140. Now the last part now is asking us a little theoretical question, like, you know. It's asking us to explain why this quadrilateral AOBE, AOB all the way out to E. Explain why this one is cyclic. Now you cannot say it is because the vertices are on the circumference of a circle, but there's no circle shown around these points. One can be drawn around it, but none is shown. This one, another thing that will make a quadrilateral cyclic is when you know that the opposite angles are supplementary, and that's what is happening in this case. The opposite angles add up to 180 degrees there, and also these two add up to 180 degrees. So this one is cyclic because the opposite angles are supplementary. So you're going to write that. Right? So AOBE is cyclic because the opposite angles are supplementary. In that they add to 180 degrees. It means that it is possible to put a circle around these. It's possible to put a circle that passes through these 4 points. The center is going to be somewhere inside this, right? A different circle. It's possible. Like, you know, it's like you can draw a circle like this, these 3 points like that, and you know, it's possible. If you try to, if you understand what I'm trying to say, it's possible to draw a circle through these 3 points. See? Something like that. It is possible to draw a circle, these, not 3, these 4 points on the circumference. Just that that circle is not shown. And then it would still be cyclic. But they did not show a circle. So you cannot say it because the vertices are on the circumference of a circle. It must be because the opposite angles are supplementary. Why it is cyclic. And that is that for today, guys. How long we going now? How long? Who can tell me how long we're going? Less than 3, about 2.5 hours.
Also 2 hours and
2 hours and what?
40 minutes. I started.
All right. All right. That's okay. That's okay. So you got some time. So did a paper, and the questions will get closer and closer. Well, that's a full length of an exam. So the questions, the papers that we do will get closer and closer to 3 hours, 2 or 40 minutes the length of an exam paper. Remember, I'm explaining and so on, so it's going to take time. So because we're doing more questions on the papers now, because we have covered more topics. Sessions where we're revising and going through a whole paper will take more time. I remember we're also going through the classwork, so you know it will take some time, but that's all right. We have to do what we have to do. It's not forever, it's just until May. All right? And we have to prepare ourselves. We want to have a good, easy time in the exam room. So we have to put in the work. All right, guys, that's it for today. I'll see you in class tomorrow, Monday, and in the week. All right? Bye, everybody. By the way, no, we won't have a Saturday session next week, Saturday, because I'll have an event next week, Saturday. So we won't have online next week, Saturday, but I might still send some work for you to do. All right. Bye. See you all soon. All right. Cool.